All right, so here's our scenario. I claim that I am an 80% free throw shooter. Just a minute. There we go. Mr. Beebe does not believe that I'm that good. To prove my skills, I shoot 50 free throws and I make 32 of those shots. So either in the chat or by unmuting your mic, I want you to let me know, what do you think the population is here? What do you think the population would be? All right, I'll give this one to you. Our population is all the possible free throws that I could take. Not necessarily make, all the free throw shots that I could take is my population. So what would the sample be then? What would the sample be? Unmute your mic or type it into the chat. What would the sample be? If the population is all possible free throws, what is our sample? Yes, the 50 free throw shots that I took. What would the statistic be? If the sample is 50 free throws, what is the statistic? Yes, 32 out of 50 shots. So my p hat would be 32 out of 50, or 0.64. So what would the parameter be? What would the parameter be? The statistic is 32 out of 50. Think about what that 32 out of 50 is telling you. That is the proportion of what? Yes. Our parameter is the true proportion of free throws made by me. All right. So now that we've got all of those pieces down, there are two possible explanations for why I only made 32 out of 50 shots. My explanation, my claim for why I only made 32 out of the 50 shots is that I really am an 80% free throw shooter. I just had a bad day. So that's one possible claim. What is the other possible reason for why I only made 32 out of the 50 free throw shots? If one explanation is it was just a bad day, what's the other possible explanation? Again, you're welcome to either unmute your mic or type into the chat. What is the other possible explanation? I lied, or that I'm just not that good and I think I am. But yeah, the other explanation is that I am less than an 80% free throw shooter. Absolutely. All right, so my claim, where I claim I really am an 80% free throw shooter, we call this the null hypothesis, which gets abbreviated H with a little O next to it. That's called a null. And we usually just call this the HO. Our null hypothesis, or our HO, is that P, the true proportion of free throws made, really is 80%. The other claim, Mr. Beebe's claim, that I am less than an 80% free throw shooter, we call this the alternative hypothesis, or the HA. The alternative hypothesis is that P, the true proportion of free throws made, is actually less than 80%. So I'm going to give you guys all a moment to get a screenshot of this or to finish writing it down in your notes. But you want this, and then we're going to flip over to an applet to test this now. So if you've not already logged into Canvas and you're not already on our page in Canvas, our course, you want to go ahead and get there. What we are going to do is we are going to assume that the hoe is true. To test this claim, we're going to assume number one. We're going to assume I really am an 80% free throw shooter. And we're going to examine the probability that only 32 out of the 50 shots are made purely by chance. So we're not going to use a Google spinner. This is where I need you guys to get into Canvas. From Canvas, if you're not already there, you're going to click on Modules. In Modules, you want to go to here where it says Chapter 9. So scroll below Chapter 8. You want to go to Chapter 9, Tuesday 121. Click on this. You're going to scroll just a little bit underneath task number 1. You're going to click on this link here that says stapplet.com/basketball. That will take you to this screen right here. And on this screen, I want you to click this bottom button that says enter an existing class code right here. Click that link, and that should take you to a screen that looks kind of like this. And the code that I want you to enter is this code right here, 9517E4. 9517E as in excellent, and then the number 4. There's the code that I want you to enter. All right, so we are going to test this out. You should see a little basketball player here. This simulation, we have a player who truly is an 80% free throw player. Hold on, I think I have to reload this page. 9517E4. There we go. All right, so what I need you guys to do now, this shoot button right here will go live in just a second. Oh, shoot. I'm going to have to start this over. Different code. My apologies. We're going to have to do a different code, guys. My apologies. All right, the new code, B15626. I am so sorry. B15626. B as in boy, 15626. So reload the page or go back and click on that link again and then enter B15626. And so here we have this little player who really is an 80% free throw shooter. And what we are going to do, all right, that button should have gone live for you now, so you should shoot. You're going to shoot 50 shots, and you can take one shot right after the other. You don't have to see whether it's missed or made. If it misses, it bounces off. If it makes it, it says a +1. It's keeping track of how many right underneath where it says shot statistics. You're going to do this until you have 50 shots. You can go through them really fast, too. So I'm going to get this up to 50. Once I hit 50 shots, it says I made 39 out of the 50 shots, which is 78%, and then it put a dot on my dot plot. And then we're going to do this again. I want you to shoot another set of 50 shots so that a second dot shows up on the dot plot for you. Every person needs to put 2 dots up on the dot plot. So go ahead and take your 2 shots. Raise your hand in teams when you have taken your 50 shots so that I know when we've got everybody. So take your 2 shots. Once you've made both shots over in teams, I want you to raise your hand so that I can see who has completed their 50 shots. So far, we are up to 26 simulations so far. Wonderful. Just waiting on a couple other people. I think we've got 2 or 3 people left that still need to complete this. If you're confused about how to complete this, please let me know. Should have almost everybody now. Raise your hand once you are done. All right. Let's go ahead and analyze this. So I'm going to take a screenshot here. All right, I'm going to move this dot plot over into the notes. Notice we had 30 dots total. If you look at the screen, it says we've got 30. N is 30. All right, so to get a sketch of it into your notes as well. Get this up. All right, sorry, it's taken me just a moment. All right, there's the proportion of free throws made. So there's our dot plot. What does each one of those dots represent in that dot plot? What do each one of those dots represent in the dot plot? Think about how the dots were made. One simulation of 50 free throws taken by me, absolutely. One random sample of 50 free throws, and specifically the proportion of makes calculated for that sample. So it's a sample of 50 free throws, and how many out of those 50 were made shots. So for an 80% free throw shooter, what is the probability that a sample of 50 shots ends with 64% or less free throws made based on this dot plot? How many of those dots came in at 0.64 or less? 0. 0.64 would be about right here. And we had 0 out of 30. All right, so I've got a 0 out of 30, which would be 0%. So what I want to write here is that when we assumed the null was true, assuming the null, HO, is true, that P is equal to 0.80, according to the dot plot, there is a 0% probability of getting P hat of 0.64 or less purely by chance. So if there is a 0% probability of getting a p hat of 0.64 or less purely by chance, do you think that we have convincing evidence for Mr. Beebe's claim that I am less than an 80% free throw shooter? What do you think? Do you think we have convincing evidence, yes or no? Give me a yes or no in the chat. Do we have convincing evidence for Mr. Beebe's claim that I am less than an 80% free throw shooter? Yeah, I agree. I think we do have evidence for that. I think what our evidence shows us is that it would be highly unlikely for me to get a sample proportion, a p-hat of 0.64, if I really was an 80% free throw shooter. Does anybody remember where our cutoff is for thinking something is suspicious? What's that percentage? Where's our cutoff there? 5%, yes. So because 0% is less than 5%, or you could say 0 is less than 0.05, we are going to reject the null hypothesis. We're going to reject the HO and do have convincing evidence that Ms. Bolt is a less than 80% free throw shooter. All right. Very nice. I'm going to leave it here for a minute in case you need to get a screenshot or finish copying down what we've written before we go and look at the quick notes that kind of summarizes what we worked on today. So if we had come up with a simulation where we had more than 5% of all of the dots at 0.64 or less, then we would say that we did not have convincing evidence for this. We had none of our simulations show up with 0.64 or less. So we ended up with a simulated sample or a simulated proportion of 0, simulated probability of 0% to get a 0.64 or less purely by chance. All right. So I am going to go over to our quick notes now, and you do not have to copy these down. These will be printed in your notes packet, but if you want to copy them down, it might not be a bad idea. Couple things that are important takeaways from today's lesson. When we do significance testing, which is what Chapter 9 is all about, we have to write hypotheses, and we will always write 2 hypotheses based around P. P is our true proportion of whatever our context is. The null hypothesis is that P equals our null value. This will usually be something that's been claimed somewhere else in the question stem or in that scenario. So the null hypothesis is whatever the claim is. The alternative hypothesis is that P is either less than that null value, P is greater than that null value, or P is simply not equal to that null value. If it's a less than or a greater than, we say these are one-sided tests because we'd only be looking at the tail on the greater than side or only looking at the tail on the less than side. If we say that P is not equal to our null value, then it could be higher or lower, and we call this a two-sided or a two-tailed test. Writing a full conclusion for a significance test. There are 2 key sentences, and I've provided you with stems for those 2 sentences that we will use in the conclusion of all of our significance tests. First, we have to interpret what the p-value means. Interpreting that p-value means assuming the null is true, assuming p equals whatever the claim is, there is a p-value probability of getting a p-hat of blank or more extreme purely by chance. So that p-value is whatever the probability showed up to be. In our problem, we had a 0% for our p-value. And then the final sentence, the conclusion of the conclusion is because the p-value is less than alpha, In this case, we used 5% as our alpha level. That's most of the time what we're going to use. If our p-value is less than alpha, we reject the null, we reject ho, and we do have convincing evidence for ha, which we will talk about in context. If our p-value is greater than alpha, then we say because the p-value is greater than alpha, we fail to reject the ho, and we do not have convincing evidence for the ha, the alternative hypothesis. And we need to write this all out in context. We're going to practice doing that a whole lot more over the next several days. Between now and then, since I can't hand you the new homework for you guys to work on, you will be receiving that tomorrow along with your notes packet, is the reading so that you are prepared for class tomorrow. It's about 7 pages, page 586 to page 592 in your book. Read those 7 pages and have that ready to go for tomorrow so that you are ready for our lesson and that you are well prepared to work on the homework that you will receive tomorrow in class. Does anybody have any questions for me? Yes. Faith, did you have a question? If you guys have questions, you are more than welcome to unmute your mic and ask, or to type it into the chat. Either one works. If you don't have any questions, you are allowed to go ahead and leave this Teams meeting so that you can get prepared for your last Teams meeting of the day, which starts at 11:09 in 7 minutes. If you have questions, hang around and ask your question. If you don't have any questions, you are allowed to leave this Teams meeting to get ready for your 7th period Teams meeting. Bye. Have a good one, Alice. Bye, Abby.